Hello everyone, and welcome back to Algebra 1 with Miss Betsy. Today we're going to be learning how we solve absolute value equations, and we're going to see that they're a little bit different than a traditional standard equation. This is the textbook that I'm using if you wish to track along with me. This is Algebra 1 for Christian Schools, published by Bob Jones University Press, and I'm using the second edition. The third edition has the topics in a different order, so you need to be aware of that if you're trying to use that same text. But again, it really doesn't matter what text you're using. The methodology for solving an absolute value equation is the same regardless of what your text is. So let's pray and let's see what the lame joke is for today and dive right into this material. Father, we love you today and we thank you for who you are. Father, I thank you for the ways that I see you evident in my life every single day. Father, help us to study today, to learn the things that you would have us to learn. Help me to communicate clearly and help the students on the other side of this video camera to be able to understand so they can apply this knowledge to their work. I thank you that you love us. In Jesus' name, amen. Okay, absolute value equations, but before we begin that, let's see which one am I going to tell you today. They're all pretty bad. Okay, where do mice park their boats? When you say mice didn't have boats, well, how many of you read about Ralph and his motorcycle? Well, Ralph also has a boat, you just don't know about this, and the mouse named Ralph parks his boat at the Hickory Dickory Dock down the road. So, absolute value equations. I'm beginning on page 150, and we start saying, okay, what exactly is absolute value? And we learned that absolute value is the distance from 0 on the number line, and that it's always positive. So here is my very crooked line here. Here's 0. The absolute value then of both 5 and negative 5 would be 5 because they are each 5 units from 0, but in differing directions. So we could say that the absolute value of a negative 5 is 5, and the absolute value of a positive 5 is 5 as well. Absolute value refers to distance. You cannot go a negative distance. You hear of going 2 steps forward, maybe and 3 steps back, but you're still traveling an actual literal distance, so there's no such thing as negative distance. Here we have the absolute value of a negative number is positive. We have the absolute value of a positive number is positive as well. And they want you to see a very technical definition of what absolute value is. Let me write that for you, and then I'll use an example here to illustrate that. But we're not going to dwell on this definition. We have the absolute value of x is equal to one of two things. It can either be the opposite of x if x is less than 0, or it is going to be x itself if x is greater than or equal to 0. Now you look at that, and without tearing it apart or pausing to consider what it's actually saying, you might be going, oh my word, what in the world are we talking about? So let's look at this and see what this algebraic notation here is really talking about. First off, we know this means the absolute value of x. This is the distance from 0. But what does it mean if we say the opposite of x if x is less than 0? Well, what sort of numbers are we talking about here? Let's look at our number line. And this says that x has to be less than 0. So that means that we are talking about all of the numbers to the left of 0 on the number line, and they're all negative numbers, aren't they? So these are just negative numbers. That's all we're talking about here. Conversely, they say that x can be greater than or equal to 0. Now, that's a little bit tricky here because it says that x can be 0 itself, but you know that that 0 is neither positive nor negative, it just is. But the second part of our definition says that x can be 0 or it can be greater than 0, which would be all of the numbers to the right of 0 on the number line. And I don't know if it was your class that I threw this marker across the room recently because it was dead. Well, I picked it up off the floor and I should have left it. So now we're going to do our red. All of the numbers to the right of 0 on the number line, and you know that those are positive because numbers to the left of 0 on the number line are negative. Numbers to the right of 0 on the number line are positive. So all that this definition here is talking about is it's letting you know a general rule for what absolute value is going to be if you're finding the absolute value of a negative number or if you're finding the absolute value of a positive number. So let's look at this now that we know exactly what they're talking about, that all of this algebra language here just means we've got two separate answers possible if we're dealing with a negative number or we're dealing with a positive number. So let's say x is a negative 5. What does this tell us the absolute value of x is going to be? Well, it says that the absolute value of x is going to be the opposite of what we have inside the parentheses. So it's the opposite of a negative 5, which is a positive. Now, it says if x is actually 0 or a positive number, positive 5, then it's simply going to be that value for x. It's going to be what we have inside the parentheses, inside the absolute value bars. So what we're seeing here and what they really want you to come away from this exercise understanding is that when you are dealing with absolute value, you have two possible answers for absolute value. Two possible values for that x. If we have an absolute value of 5, x itself can be either negative 5 or positive 5. If we have an absolute value of 2, x can be either negative 2 or positive 2. Obviously, if you have x is equal to 0, there's only going to be one solution, which is 0. But in general, when you have absolute value equations, there are two possible values for x. And that's what they go through some theory to teach you, and what I'm not going to dive into any further than this. You can look in your book and learn some more. But what I want to show you is the practical way that we arrive at our solution for absolute value. And let's just see. What if we had x plus 3 is equal to 5? The absolute value of x plus 3 is equal to 5. And what we just said was that for this one answer, 5, there were two possible solutions. Either it was going to be equal to everything that was inside those absolute value brackets, or it was going to be equal to the opposite of everything that was inside those absolute value bars. Now, I'm sort of doing this right off the cuff here, right off the top of my head. I really hope that it's going to work. Okay, let's see what we have. If we distribute this negative sign here, we have 5 is equal to the opposite of x minus 3. I'm just solving this equation right here. We're going to add a 3 to both sides of our equation here, plus 3. our equations in balance, right? So we have 8 is equal to the opposite of x. Now we're going to divide both sides by -1. And we have x is equal to a -8. And you might think that just doesn't make any sense at all. Well, let's substitute it back in to this equation up here. The absolute value of -8 plus 3, is that equal to 5? Absolute value of -5, is that equal to 5? Yes, 5 is equal to 5. So we have one possible value for x here, and we have another possible value for x here, which I'm not even going to take the time to solve, because you know that x can be equal to 2. Now, do you see what I did here? I have two possible values for x. X is equal to 2, or x can be equal to a -8. And that's the only thing I'm going to leave right there while I erase these two different possible answers that I had. Let's come back to, and hang with me here, come back to this problem. Let's see if it's true. That's how we know to check our solution. I'm going to just substitute in absolute value of 2 plus 3. Is that equal to 5? Yes, the absolute value of 5 is in fact equal to 5. We know that. That's an easy one. But what happens, it just doesn't, it messes with your brain maybe to think -8 can have anything at all to do with +5. Well, like I just did, and I'm going to redo for you now, we have the absolute value of -8 plus 3. Is that equal to a +5? Remember that absolute value bars work exactly the same way as symbols of inclusion. So I have to add within those absolute value bars first. Absolute value of -5. Is that equal to a +5? And yes, 5 is in fact equal to 5. So what may have turned your mind a little bit was when I said that 5, an absolute value of 5, has two possible answers. And we came at that from using the original definition of absolute value. Our original definition of absolute value said that the absolute value of x is equal to the opposite of x if x is negative. Remember, it was if x was less than 0. If it could be the opposite of x if x is negative, or it could be x itself if x is positive. So that means that when we have the absolute value of -5, because this is negative, we're going to take the opposite of x to give us a +5. We take the absolute value of 5, x is positive, so that absolute value of 5 is a +5. And all I did was take this and turn it around and say that when we have an answer of 5 for an absolute value, there are two possible solutions, two possible values for x. That's what I illustrated for you right now. What you may still be sitting here and scratching your head and thinking it really doesn't make any sense. Let me show you very clearly how that Hopefully I didn't mark into that. I think I did. How that works out for you in real life. All this means is this is what you're going to do to solve an absolute value equation. And I'm going to look on page 152. It says solving absolute value equations. It says first, simplify as much as possible within the absolute value signs. Isolate the absolute value on one side of the equations and all other quantities on the other side of the equation. That makes sense. Write two equations by applying the difference of absolute value. This is what they mean for you to do. Do this every single time and you'll not have any difficulty at all with absolute value equations. This is example 1. It says the absolute value of 2x plus 5 is equal to 11. This is example 1. Now, this is a point where you could get confused. What are they talking about when they said x is the absolute value of x? They're talking about everything that is within the parentheses. I'm sorry, everything that's within the absolute value brackets here. This is what you do. You take whatever is inside the absolute value bars. That is what x is equal to. Follow me with this red. I'm going to circle this right here. This is x. The whole entire quantity within the absolute value bars. And that's where our our definition of absolute value comes in. It says x is equal to the opposite of x or x itself. That's what they're coming from. Our equation is in balance, so we're going to take this value here of 11. We're going to say that 2x plus 5 can either be equal to 11 or it can be equal to the opposite. 2x plus 5 is equal to the opposite of 11. Every absolute value equation is going to break down for solution into two equations. You take what's inside the parentheses, set it equal to exactly what you already have in your equation, or set it equal to the opposite. Let's see what happens. We know how to solve this. We subtract 5 from both sides of the equation, which I'm not going to do the work. We have 2x is equal to 6. X is equal to 3. Or we have 2x is equal to negative 16. X is equal to a negative 8. Now let's see, does this really work? Because according to the work that we have done right now, our solution would be x is equal to 3 or x is equal to negative 8. So we're going to have to check with both of these values here to see if we end up with a true statement. The absolute value of 2 times 3 plus 5, is that equal to 11? You already see that it is. Absolute value of 6 plus 5, is that equal to 11? Yes, the absolute value of 11, of course, is equal to 11 because it's positive. So that one works. What about this one over here, though, with this bizarre negative number? Well, just substitute it in. The absolute value of 2 times a negative 8 plus 5, is that equal to 11? Remember, absolute value bars function as symbols of inclusion, so you have to work within those absolute value brackets first. Negative 16 plus 5, is that equal to 11? Well, here is where the absolute value of a negative number kicks in, and we see that we definitely have a true statement. All right? This is all you're going to have to do to solve equations that deal with absolute value. You just remove your absolute value bars and you have two equations. Missed it. So let's do another example, or two, or three, and see what we have. Okay, example 2 on page 152. Let's see what we have. This says, solve 5 plus absolute value of 2y plus 4 minus 5y is equal to 21. Well, that was certainly a jump in the type of an absolute value equation that we're going to solve, isn't it? But remember, our variables are in here within the absolute value bars. You have to combine within the absolute value bars first. So that means we want everything not within the absolute value bars on the opposite side of the equation. So if we've added 5 here, we're going to have to subtract. So we have 5 minus 5 times this absolute value. And I can combine two steps here. I'm going to combine within the parentheses negative 3y plus 4 is equal to 21. Is that all I do? No. Don't forget that you have to keep your equation in balance by subtracting that 5 from both sides of the equation. Now we have 5 minus 5, which of course is 0. The absolute value of negative 3y plus 4 is equal to 16. Now, I'm just dropping things all over the place. Now we're at a point where we can solve this absolute value inequality, in this absolute value equation. And what did we say we want to do? We're going to take x, which is everything that is within the parentheses. In other words, within the absolute value bars, in other words, you take, once you have simplified, as we did, within the absolute value bars, you simply remove them to form two equations. One equal to the actual value on the right-hand side. The second equation is equal to the opposite of that value. And this is where the definition of absolute value comes in. Negative 3 plus y, negative 3y plus 4 is equal to 16, or negative 3y plus 4 is equal to the opposite of this 16. Now we have the two solutions. We're going to subtract 4 from both sides of the equation. Minus 4 is equal to 16 minus 4. Our equation remains in balance. Negative 3y is equal to 12. We divide both sides by a negative 3. And first, we have that y is equal to a negative 4. Going to solve our second equation now. Once again, by subtracting 4 from both sides of the equation. But we are going to end up with a different value, aren't we? 16 minus 20. Opposite of 3y, whoops, I said negative 16 minus 20. I was doing my subtraction. Negative 20. We divide both sides of this equation by a negative 3. Remember our rules for dividing negative numbers, for dividing integers, and we have that y is equal to 20/3. So we have two possible values. Either y can be equal to a negative 4, or y can be equal to a positive 20/3. So how do we verify that? Well, we substitute into our original absolute value equation. So let me write out to the side, y can either be negative 4 or 20/3. And just when you're beginning to work with these absolute value equations, that might just look like a really weird answer. But hang in there and check it, and you will see that it's going to work. So here's our check. 5 plus the absolute value of 2 times -4 plus 4 minus 5. Okay. Minus 5 times a -4. Is that equal to 21? And I'm not even going to combine in there and say -3y. 5 plus -8 plus 4 plus 20. Is that equal to 21? 5 plus the absolute value of 24 minus 8. 24 minus 8 is 16. Is that equal to 21? Yes. 21 is equal to 21. And it's usually going to be pretty straightforward. One of them is going to be an obvious answer. The other one may be just a little bit stranger looking, but when you work through the check, you'll see it works. 5 plus the absolute value of 2 times 20/3 plus 4 minus 5 times 20/3. Is that equal to 21? We're going to have to simplify within the absolute value bars. 5 plus the absolute value of 40/3 plus 4 minus 100/3 absolute value. Is that equal to 21? Now I'm not going to show you the fraction work here. If you need help, send me a text. 5 plus the absolute value of -60/3, not 60/30, it's -60/3 plus 4. Is that equal to 21? What is the -60/3? 5 plus the absolute value of -20 plus 4. Is that equal to 21? What is -20 plus 4? It's a -16. And what is the absolute value of a -16? It's a positive 16. So we have that 5 plus 16 is in fact equal to the absolute, is equal to 21. So y is a -4, or y may be equal to 20/3. And this was a much more involved check, but when you step through it, you see that it's true. So in summary, you will always have two solutions to an absolute value equation unless that solution happens to be 0, because 0 is its own opposite. So let me work one more for you. And I'll pick one randomly that is just a really straightforward one. It says problem number 8. Absolute value, problem number 10. Absolute value 3z plus 4 minus z is 16. 3z plus 4 minus z, that absolute value, is equal to 16. And let me tell you again what number this is. This is problem number 10. Absolute value bars work just like parentheses. Absolute value of 2z plus 4 is equal to 16. We get to the point where we have simplified as much as we can within the absolute value bars, and only the expression that is the absolute value is on one side of the equation. Everything else is on the other side. When we have it in this form, this is when we come up with two equations to solve. Either 2z plus 4 is equal to 16. All I've done is I've taken the entire expression minus the absolute value bars and set it equal to the original quantity, which is 16. The second time is to take that expression within the absolute value bars, which is 2z plus 4, and set it equal to the opposite of this number, negative 16. You solve both of those equations. 2z is equal to 12, z is equal to 6. 2z is equal to negative 20, z is equal to negative 10. So right now it looks as though we have two values, a positive 6 or negative 10. And you might be thinking, okay, absolute value is supposed to be the same distance from 0 on the number line. 6 and negative 10 are not the same distance from 0 on the number line. That's true. It doesn't have anything to do with that, because what we have that we're taking the absolute value of is an expression within that has to be simplified. That's why we have different numbers when we're solving these absolute value equations. Here's our check. And I didn't do this ahead of time. 3 times 6 plus 4 minus 6, absolute value, is that equal to 16? Simplify within the absolute value, brackets, 18 plus 4 minus 6 has a net effect of minus 2. The absolute value of 16, of course, is equal to 16. This one works. Let's see what happens with this value over here. Absolute value of 3 times a negative 10 plus 4 minus 10, is that equal to 16? Simplify within the absolute value brackets again. Minus 30 plus 4, minus 10. Okay, what did I do wrong? Let's see. 3z plus 4 minus 10. Negative 10. Negative 30 plus 4 minus 26. Okay, can't add in my head. That was a little bit scary to me. Is that equal to 16? I have the absolute value of a negative 26. Okay, who sees what I did? I make it a point when I have a problem here not to redo this, because I knew that this answer had to work. It works up here. This is what I've said. When you substitute in, what have I said? Especially when you have negative numbers, you should enclose that in parentheses, because if you don't, you're prone to dropping the negative sign. And that is exactly what I did here. Let's rewrite this. What does my original equation say? Absolute value of 3z plus 4 minus z. Notice I just put minus 10, but what is the value for z? It's a negative 10, so that should be minus a negative 10, equal to a negative 16. And that's where I got myself in trouble. I say over and over and over, negative signs trip you up. Dropping a negative is a very common mistake, and that's what I did. Now I have 3 times the negative 10 is negative 30 plus 4 minus a negative 10 becomes plus 10, and now our problem is going to work out. Is that equal to a negative 16? Negative 30 plus 4 is a negative 26, plus 10 instead of the minus 10. Plus 10, is that equal to a negative 16? Yes, the absolute value of a negative 16 the absolute value of a negative 16 is equal to 16. You have to substitute into the original equation. the absolute value of a negative 16 is equal to 16. The equation, the second equation that we used to find the solution, this right here is negative. Has to be like that because that's how we come up with two equations when we're using our absolute value. However, when you do your check, you do not use your check with this equation. You use your check back to your original, okay? So, hang in there, work on these. If you get stuck, send me a text or ask me a question on Friday, and I will see you then.